Morning, Robert Scribbler here with a remote session of the OBX Wave Report. I am back up in my old stomping grounds of Gaithersburg, Maryland, taking care of some business. But nonetheless, I will not forsake my OBX Wave Report watchers, and we've got a lot of extreme weather and climate news for today. But I do want to start out with a little bit of a preamble talk about the waves. Right now, the waves are small across the Outer Banks, ranging in the 1 foot area, 1 foot waves over most beaches in the Outer Banks. Occasionally, you'll find a beach that has 1 to 2 feet, namely Buxton. And then the south-facing beaches with some southerly wind and some southerly swell are starting to get decent waves. So places like Billy Mitchell getting waves in the range of 2 to 3 feet, or Frisco in the range of 1 to 2 feet. I'm going to get into a more comprehensive overview of the waves across the Outer Banks for our wave observations and wave forecasts. But for right now, let's jump into extreme weather and climate change. And right now, we're getting reports in that Fort Lauderdale has been inundated with an unprecedented deluge in which 25 inches of rain were dropped over an 8-hour period. What happened at Fort Lauderdale? Um, well, it's pretty simple. There was a powerful thunderstorm that sat over Fort Lauderdale for hour after hour after hour. This storm was fueled by warmer than normal ocean temperatures in the Gulf of Mexico and in the Atlantic, allowing it to hold more moisture than it typically would. And the weather conditions were such that the storm remained stationary. Um, there are climate fingerprints all over this storm. Recent studies have shown that the US South is expected to see more supercell thunderstorms generally as a result of climate change, the warming of the Earth's atmosphere and ocean. Thunderstorms are essentially heat engines, and they feed on heat. They feed on convection. They feed on moisture evaporating off the ocean surface and off the land surface. And if ocean surfaces and land surfaces are warmer, they're going to pump more moisture into the atmosphere, lending to the intensity of storms. It's also worth noting that with climate change, you can have areas of weather that get stuck in a pattern for a long period of time, be it rainfall over a certain region where the weather systems don't move, or drought and heat over a certain region for long extended periods of time. I would like to refer you to the climate experts, and I'm going to go ahead and cite the study that I referenced just now later on in the WAVE report. But I encourage you to check out your local weather experts on the issue, and your climate scientists. One of the climate scientists that I tend to follow is Dr. Michael Mann. The Intergovernment Panel on Climate Change is the presiding body globally, and a fantastic scientist on the issue of climate change is Gavin Schmidt, as well as Catherine Hayhoe. I'm just referencing names of climate scientists that will likely provide statements on extreme issues should they feel that the need arises. In any case, definite climate fingerprints on this storm. And I did want to show you some of the Twitter feeds. This one, Aaron Parnas, Fort Lauderdale, Florida, after record-breaking floods overnight, where you see just stranded vehicles all over the street. The airport, notably, was flooded, and GOP once again kind of AWOL. DeSantis way out in Ohio as his state is getting inundated by floods enhanced by climate change that in his rhetoric he seems to deny. So yeah, total lack of leadership there. And I did want to show you this weather radar showing this thunderstorm cell here, and it just sat there for hours and hours and hours and rained out over Fort Lauderdale, producing up to 25 inches of rain over the period. Um, and the study that I referenced earlier was that warming-fueled supercells will hit the southern U.S. more often. The study showed that global warming enhanced the strength of supercell thunderstorms, particularly for the U.S. Southeast. And let's see. The study was published in the Bulletin of the Meteorological Study, a part of the American Meteorological Society, and it was entitled "The Future of Supercells in the United States." Um, and it just no, I'm going to read a portion of the abstract. A supercell is a distinct type of intense, long-lived thunderstorm that is defined by its quasi-steady, rotating updraft. Supercells are responsible for the most damaging hail, deadly tornadoes, causing billions of dollars in losses and hundreds of casualties annually. This research uses high-intensity convection permitting climate simulations across 15-year epochs that span the 21st century to assess how supercells may change across the United States. Specifically, the study explores how late 20th century supercell populations compare with their late 21st century counterparts for two intermediate and pessimistic anthropogenic climate change trajectories. So basically, it simulated a mid-range climate pathway or a high emissions climate pathway. And the finding was that supercell storms, particularly, were more frequent in a warming environment. And I encourage you guys to check out this study. I am not certain if this particular storm here in Fort Lauderdale was a supercell or qualified as a supercell. Nonetheless, a very intense thunderstorm, and thunderstorms are in and of themselves heat engines. Okay, I do want to look at the global forecast system model summary of precipitation just to show you what this cell was associated with. Now, I've been talking about this storm system in the Gulf of Mexico over the past couple of days and the warmer than normal water temperatures that were fueling it. And so this thunderstorm, this powerful thunderstorm cell that dropped 25 inches of rain, possibly a supercell thunderstorm, emerged as part of this system forming in the Gulf of Mexico over warmer than normal waters. And right now we're looking at the rainfall models, and you can see that this particular thunderstorm here over Fort Lauderdale was not as intense as some of the thunderstorms out over the Gulf of Mexico. Nonetheless, over land, producing 25 inches of rain. I'm going to go ahead, let's back this up to when the storm starts. Okay, and so you can see the stationary nature of the system involved. We've got a front draping over the Gulf of Mexico, a low pressure cell forming in the Gulf, and this thunderstorm forming over Fort Lauderdale. And I'm just going to go ahead and go hour by hour as this storm dumps out over Fort Lauderdale under the green dot here. But if you look to the west there and see those storms over the Gulf, just imagine if those things were over land. So yeah, a very intense cell over Fort Lauderdale and massive amounts of rainfall, 25 inches of rain associated with a low pressure system and a stalled front stretching from the Gulf of Mexico over to the Atlantic Ocean. And now I just do want to show you the ocean surface temperatures and the sea surface temperature anomalies. Let's go to currents. And so here in the Gulf of Mexico, ocean water temperatures are in the range of about 1 to 4.5 or a half degree to 5 degrees Fahrenheit above normal, averaging about 2 to 3 degrees Fahrenheit above normal. Out here in the Gulf of Mexico, just off of Fort Lauderdale, ocean water temperatures in the range of about 1.5 degrees Fahrenheit above normal. So much warmer than normal ocean in general, helping to fuel this thunderstorm. And we've had generally warmer than normal ocean temperatures in the Gulf. And that is one of the triggers for severe weather in the US. All right, let's shift to El Nino. And I've got some new reporting on El Nino for you from Ben Knoll, one of our climate experts. And what what has been what Ben is reporting is that the Nino index, and this is a measure of the intensity of heat at the ocean surface in the eastern equatorial Pacific, is near record levels. So we are seeing very extreme ocean surface temperature deviation right now in the range of about couple of spots right now in the range of about 9.5 degrees Fahrenheit above normal, nearly 10 degrees Fahrenheit above normal in some locations. This is close to the warmest we have seen the eastern equatorial Pacific on record, measure for April. So this is near unprecedented state. And I'm just going to go ahead and read the statement from Ben Knoll. This from April 11th. Update on the El Nino Costero unfolding. They're naming the El Nino now, so this one is Costero, unfolding off the coast of Peru and Ecuador. Sea surface temperatures are locally 5 to 7 degrees Celsius above average. Marine heat wave conditions are widespread. The daily Nino 1 plus 2 index, Nino 1 plus 2 is this region off of Western South America in the Eastern Equatorial Pacific. So the daily Nino 1 plus 2 index is plus 2.99 degrees Celsius. The only time it was higher in April was in 1998 and 1983. Both very severe El Nino years. And this might be one of the reasons why some of the El Nino experts are pointing toward a super El Nino potential, because the El Nino 1 to 2 index is in the super El Nino range. I've been doing some digging because the models weren't really pointing toward super El Nino type event, but but the Eastern Equatorial Pacific is um, lighting off with a high degree of heat, and that is certainly cause for concern. If we do have a super El Nino event, global temperature records will tend to push higher, and or global temperatures will tend to push higher, and the likelihood of hitting new record global temperatures is greater. Um, and and so we might see higher risk of new record global temperatures for 2023 and 2024, and we're already actually starting to see some of that. It's worth noting that there's some kind of a handshake going on right now between El Nino and record global ocean temperatures generally. The global ocean system is much hotter than normal, and the overall global heat, of course, is driven by fossil fuel burning, which is driving the entire climate crisis. And we wouldn't really be talking about um, or freaking out about El Nino as much if we didn't have the underlying effect of fossil fuel burning turning what is a normal feature of the climate system into something that is so dangerous. And that is what is happening right now with El Nino. All right, so let's get into some of the weather observations for the lower 48. The storm that formed over the Gulf of Mexico has moved into the U.S. southeast and is setting off thunderstorms and severe weather. And we've had this added punch of severe weather because of this storm system swirling up out of the Gulf and getting into the U.S. southeast. So we have increased risk of severe thunderstorms across parts of the eastern and central United States. We'll get into that more. We can see the swirl of the storm clouds in the geocolor composite, which I just updated. You can see it over here, swirling over parts of Alabama, Mississippi, Tennessee, Kentucky, Georgia, North Carolina, Virginia, etc. Fort Lauderdale, thankfully, has cleared out. Hopefully, they won't get any more severe storms. And we do have a cold impulse coming in over the Rockies, providing the instability for those storms. In the Outer Banks, we've got thunderstorms and showers sweeping across the area. Relatively calm wave conditions, but nonetheless, some risk of thunderstorms today. And I'm going to go ahead and show you guys the National Weather Service radar summary and alerts, and you can see those storms moving across the Outer Banks. Looks like we've got some small craft advisories up for areas south of Oregon Inlet running down to the Carolina North Carolina, South Carolina border, and we've got some thunderstorms moving across the Outer Banks and the nearby coastal waters with a severe, it looks like a severe thunderstorm warning here just offshore of Ocracoke, possibly yeah, it looks like just heading just offshore of Ocracoke. We'll have to keep an eye on this. Sometimes thunderstorms heading the sound can really pump up, and we do have a lot of heat in the atmosphere and some instability, so could be pretty stormy in some locations for the Outer Banks today. I did want to also note that the fire weather hazard is not as bad as it has been over such a broad swath over the past couple of days. Nonetheless, parts of Texas, New Mexico, Oklahoma, and Kansas, and Colorado under the gun for fire weather, and parts of the Great Lakes region also under the gun for fire weather. That is another odd thing. It's worth noting. Another climate change related issue. Poughkeepsie, New York hit 90 degrees yesterday. Um, and that's just something else, all the way up in Poughkeepsie, 90-degree temperatures. And yeah, anytime there's an extreme warm record over the globe, that has a climate change fingerprint on it as well. So climate change fingerprints all over the place. Looking at the enhanced cloud tops, we can see some of those storms, the thunderstorms rolling across the Outer Banks. We've got that swirl in the atmosphere that moved up from the Gulf of Mexico, providing that instability and lift in the atmosphere over the U.S. east and south, and then the cool air coming in from the north, which is also injecting some instability as well. Okay, let's get into the wave report for the Outer Banks today, and I'm going to start out at Jeanette's Pier as I always do. And right now, these are local observations. Jeanette's Pier waves are in the range of 1 foot. Primary swell coming in at 9 seconds at 0.6 feet. That's out of the east-northeast. Secondary swell coming in at 7 seconds. That's out of the southeast at 0.7 feet. So very small waves. According to the wave monitors there at Jeanette's Pier, winds are out of the south 8 miles per hour. That is a cross and offshore flow. Air temperature in the range of about 70 degrees. Ocean water temperatures hanging in there at 54, still pretty cold. Cloudy with showers, possible thunderstorms today, 60% chance of rain, highs in the mid 70s. And looking northward to Abalone Street, we've got 0 to 1 foot waves for a spot observation. And then heading on south past Body Island Lighthouse to S turns, we find that the waves are also in the range of 1 foot with a primary swell coming in at 7 seconds. This is a 0.8 foot swell coming in out of the east-southeast. Secondary swell coming in at 9 seconds has a 0.6 foot swell also out of the east-northeast. Winds out of the south-southwest at 8 miles per hour. Air temperatures 69 degrees Fahrenheit. Ocean water temperatures a bit warmer down there at S turns at 56. And then moving on south to Rodanthe, we've got 1 foot waves. And at Avon as well, looks like I lost my Google Maps. Oh, no, there we go. Okay. Avon as well, 1 foot waves. And then heading on down to, this is Avon here, near the Avon Fishing Pier, so 1 foot waves. And then heading on down to Buxton, we've got 1 to 2 foot waves where Buxton is really, really trying to produce some better waves here. But in order to get the decent waves, you've got to go to the south facing beaches today. Billy Mitchell Airport in the range of 2 to 3 feet with a 3 foot swell coming in at 5 seconds out of the south. And for the primary swell, secondary swell coming in at 1 foot at 8 seconds out of the east-southeast. Winds at Billy Mitchell 11 miles per hour out of the southeast. Air temperatures 70 degrees. Ocean water temperatures much warmer at 64 degrees. And for the weather, pretty much the same everywhere across the Outer Banks. Cloudy, showers and thunderstorms possible, 60% chance of rain, highs in the mid 70s. All right, so that concludes our local spot observations for the waves. Let's get back to climate observations and longer term weather model forecasts. And Right now, the global temperature anomaly is in the range of zero point 0.5 degrees Celsius above the 1981 to 2010 reference period, which is already above normal. We've got much above normal temperatures here in the eastern United States and parts of the central United States. The Antarctic is much warmer than normal at 1.069 degrees Celsius above normal. Tropics are heating up with the El Nino influence starting to take hold, and the Arctic as well is above normal. No major climate zones showing below normal temperatures, although of course we do have cool variance in spots. But overall global temperature anomaly much warmer than normal. This data provided by the global forecast system model versus the CFSR reanalysis for temperature departures and the graphic provided by Karsten Hustein. Check Karsten out. He is a fantastic climate observer. All right, so let's get into our 6 to 10 day temperature and precipitation outlooks. And for temperature, it looks like above normal conditions are expected to continue for parts of the US east and south, focusing in on Texas and New Mexico. Right now, we've got some pretty serious drought situations in this region of the country with above normal temperatures expected for this region. Those drought conditions are probably going to worsen, especially when we consider that a broad swath ranging from New York moving down toward the Gulf and across Texas and parts of the Southwest are expected to see below normal precipitation. And above normal precipitation expected for the Pacific Northwest and parts of the far southern Gulf Coast region, the southern tip of Florida, and the southern tip of Texas. This over the next 6 to 10 days. Looking at the NOAA quantitative prediction forecast, the areas where storms are most likely to occur appear to be just off the Outer Banks here, over parts of the Gulf Coast region, over parts of the upper Mississippi River Valley and Great Lakes, and over parts of the Pacific Northwest. Worth noting here that the Southwest is expected to be pretty darn dry, and that is a concern. All right, looking at the severe weather potentials, we've got a lot of severe weather potentials in the convective outlooks over the next few days. So for today, we've got severe thunderstorm potential for parts of Oklahoma, Kansas, and Nebraska. And we've got thunderstorm potentials over wide swaths of the US, including much of the southeast and a big chunk of the central US. For, let's go back, for tomorrow, the Mississippi River Valley region comes into play for potential for severe weather and supercell thunderstorms, running from Texas, Louisiana, and parts of western Mississippi up through Arkansas and Missouri and extreme southwestern Illinois. So please pay attention to your local weather experts and your emergency weather statements. And then we're going to get into, let's see, Saturday and Sunday. Also, we have severe weather potential over parts of Georgia and South Carolina, heightened. Marginal severe weather potential over a very broad swath ranging from Florida up to the Great Lakes region, and thunderstorm potential mostly for the US East. All right, now let's get into the global forecast system model summary. And right now we've got thunderstorms over parts of the southeast, focusing in on the Outer Banks. These are expected to move off to the north and east over the day today and into tomorrow. And then by Sunday, we get a strong frontal system sweeping in through the Mississippi River Valley region, likely lighting up some pretty severe weather along the Gulf Coast region, looks like. And then this storm system is expected to sweep on eastward as a front comes through behind it. All right, now let's get into our wave forecast. So let's get back to the global forecast system model composites. Let's get to now. Let's get to the ocean and let's get to the waves. All right, so getting down to the waves. Um, and in the near offshore environment right now, off the Outer Banks, wave heights are in the range of about 1.5 to 2.5 feet. Small swells offshore, angling directly towards shore, but not translating very well to shore, according to the wave monitors. By tomorrow, getting into Saturday, we get a south swell starting to kick up. And this south swell is in the range of about 3.5 to 4 feet. So not too bad. It looks like over time we might get some wraparound, depending on where you are. If the swell is angling more out of the southeast, we'll tend to get better waves. Most of the wave forecasts I've looked at the coastline are ranging from 1 to 2, maybe 2 to 3 feet, depending on which wave forecast you're looking at. So we shall see. Is it going to be small? Is it going to be medium as we get into the day on Saturday and Sunday? And then by Sunday, the wave models show slightly smaller swells in the near offshore environment in the range of 2 to 3 feet, swells coming in at the south angle as well. And then as we get into Monday, another impulse of southerly winds is going to kick up that south swell a bit more, ranging from 3 to 5 feet in the near offshore environment. And then by Tuesday, looks like strong west winds will probably blow the swell out for most of the east-facing beaches. Let's see. Just want to make sure. Yeah, it looks like the direction of the swell is heading from west to east. And in that case, sounds to me like a flat Atlantic Ocean, if that is indeed what happens by Tuesday. And I believe that's it. Yep. So thank you for joining me for this session of the OBX Wave Report. We did talk a lot about climate. I did do a little clean energy special feature up here in Gaithersburg where I saw an electric vehicle charging station. Um, Whenever there's bad climate news, it should make us feel even an even greater sense of urgency for mass deploying clean energy. Clean energy is the way that we tamp down the impacts of climate change. And right now, the readily available clean energy sources that we have for mass deployment and for a fast learning curve are wind, water, solar, and electric vehicles. And that's the tip of the spear for reducing our carbon emissions. We've got other technologies out there that are kind of waiting for breakthrough or waiting to see if they're viable economically. But those right now are the ones that are living and thriving in the global economic system. It does look like that there's some potential for hydrogen in certain applications. There's been a lot of big talk about hydrogen, but not a lot of big results yet. And despite massive amounts of dollars being invested. Nonetheless, it's probably very helpful to mass deploy those electrolyzers which produce the hydrogen to reduce the cost of the hydrogen because hydrogen is probably going to be useful for things like materials and possibly aircraft and shipping and possibly long haul trucking. We shall see. But in any case, the main drivers of emissions reduction are once again wind, water, solar, and electric vehicles. And we need to double down on those sources to get to 80, 90% carbon emission reductions as rapidly as possible, and then do the rest of the things that we need to get to net zero after we achieve those massive carbon emissions. Climate scientists right now are pointing to the fact that we need to reduce emissions by 50% or more in the next 10 years to avoid some of the worst impacts of climate change. All right, so thank you for joining me for this session of the OBX